once again with this notation, we're finding the sum function, which f plus g represents the single function, the answer, and all you do is you add up the two functions you're given. Once again, the notation is different here. This is a single function that's found by adding these two separate functions. Now here, watch. Graphically, you could do this. I'll make this really easy. Let's say I have a constant function added to, well, that's too boring. Let's say you have this linear function, and I want to add them. Well, then, where the zero is easy. When I get to like right here, this part gets added on right here. So your y value for your new function is that much above that. Here is farther above, so that distance there, I need to kind of estimate maybe like that far above. And then when I come over here, it's that far above the curve. Maybe here. And when I get over here, it's that far above the curve, except for the parabola is down here at 0 now. And so it's going to make it into kind of a lopsided looking parabola. Something like that maybe. And then if I kept going, the parabola actually goes on, and so the parabola kind of takes over. It's going to, I think I was off. Anyway, you get the idea, hopefully. If not, it's okay. We're not going to do the graphing. Here, this first one is simplicity itself. All we're going to do is add. This is on your paper. Write it down. We're going to add f plus g. So we're doing x squared minus 2x plus 3x minus 4. I think last part I didn't even write the problem down because all you can do is combine like terms. That's x squared plus x minus 4, and we're done. That answer represents f plus g of x. Okay? Now it also asks for the domain of these. It's simplicity itself on these first ones because the domain here is all real numbers. The domain here is all real numbers. The domain here is also obviously all real numbers. So there's no question about what the answer is. Okay? Next, we're supposed to find f minus h. So here you have to be more careful. Once we're just going to subtract f of x minus h of x. So there's f minus. Notice I'm using parentheses this time. If you're going to write it out, you must use parentheses. Now I'm going to go ahead and simplify it. When you drop parentheses, these signs change, right? That becomes plus 2x squared, and this becomes minus 1. And so the x squared terms become combined to be 3x squared, and then you just bring down the single x term and the single constant, and you're done. That represents f minus h of x. Not hard, but seriously, don't get a sign error there. A lot of people put a plus 1 there, and then, well, that won't be nice enough. That's the whole trick, is getting that single sign right. Everything else, everyone get right, except for that sign. All right. Now we're multiplying, so we have to do f times g. So that means we're doing x squared minus 2x times 3x minus 4. You just FOIL it out. If you do first times first, you get 3x cubed, right? Then outer gives you minus 4x squared. The inner two give you minus 6x squared. And the last, positive 8x. This time you do get some like terms. So the middle two terms are both squared terms. Combine those, and we're done. That's your product function. By the way, I just have to forewarn you. Right now, that represents, the dot is multiplication, right? Later, we'll talk about the composite function, which uses a different symbol, an open circle instead. So just be careful. They're similar, but not the same. And the domain is all real numbers again, by the way. They're all polynomials. It's going to be a domain of all real numbers. All right, this one. Find the quotient function, you just do h over f. Now, whenever you have a quotient as your answer, you should simplify it, or try to simplify it. Can you factor either one of these? The numerator or the denominator? Denominator, yes. Numerator, no. So listen, I will take this either way. The main reason we factor is so we can cancel, but there's nothing to cancel. Okay? So I'm saying you can't really simplify it. I'll take it either way. Factor form or actually simplified. But you can't cancel anything. And then once again, that represents the quotient function, h over f of x. That's our answer. The domain this time, those not real numbers. The domain of both these was all real numbers, but not this. The domain is everything except for which two numbers? 0 and... Because when you plug in 0 here, you get 0 for the denominator, and when you plug in 2 in here, you get 0 for the denominator. And you can see factoring was helpful, actually, with the domain question. Okay? I want you to change the next example. We're just going to do the quotient part. Okay? Change f to be x squared minus 3x. We're supposed to find f over g of x. So we'll do f of x over g of x. So x squared minus 3x over x minus 3, which you probably already are realizing you can factor that numerator. And so, that cancels, so the answer is x. Except that's wrong. Listen, hold on. Just bear with me. The answer, this is supposed to be, the answer represents this function, right? The quotient function, okay? So what is a function, though? Good. Which, that's not the actual definition. That's a way to check if it matches the definition. You have a graph? Good. So why does it pass vertical line test if it's a function? Because a function is a set of points where what is true. That's it. That's all it is. A function is a set of points where for every x there's exactly one y. Okay? There's no more than one y. So, I'm saying, if you look at a graph, you're looking at a graph that represents the function. If you look at an equation, the equation is not a function. Equation is the rule that the points obey. Okay? So, I'm saying, we were supposed to find the quotient function. This is definitely the answer right here. What's the domain of this? Come on, what's the domain of that function? Everything except for... What's the domain of this? Everything, which means it's wrong. This is clearly the answer. We're supposed to do f over g. This is f over g. This is the answer. It's just not simplified. But I'm saying our simplified answer should match, shouldn't it? Look, what this tells us is the fact that it cancels like that and we got just x means if you graph this thing, either by hand or in the calculator, let's say you graph in the calculator, you would see that. It looked like a line, except if you go to 3 and look in the table at 3, what would you see? Nothing. It's undefined at 3. Why? There's a hole there. So actually the graph doesn't look like that. Of course, in the calculator you can't see a hole because it's microscopic, right? There's one point missing out of billions, and they're right next to it. But there is a gap there. So I'm saying, to be a complete definition of this function, you need to write that down. And I don't care if it asks for the domain or not. That's a separate question. I'm saying the function that we're talking about is all the points on the line y equals x except for that one, which you can clearly see here. But this is supposed to be a simplified version of this. So this is not optional. It's not a little extra that you only put if it asks for the domain. It's part of the definition of our set of points. It's the definition of our function. You need the equation y equals x together with the domain restriction. Otherwise, you're wrong. Okay? Say again? I'm saying this is not simplified. This is the simplified answer. And think about it. What does this look like? If you graph this, what do you get? I don't know. Turns out you get y equals x with a hole. So I'm saying I want to see what I circled. I'll give you partial credit, some credit for the left side. Actually, not much code, though, because you didn't do anything. I mean, you set it up, but you didn't know how to cancel. So, I definitely expect this. But not just X, but X with the domain restriction. Okay? All right. Once again, that was all pretty straightforward. You just multiply, divide, whatever it is tells you to do that. And then it could be, just be careful that you express the answer correctly. If it does simplify, keep the domain restriction is all. Now we're doing composition of functions. This, look at this. It's the same thing we did before. In other words, here you're composing two functions. The answer is called the composite of the two functions. So this notation represents a single function that's found by doing what you see on the right side. One thing you need to be aware of is that the order matters with this. If you switch the order, you get a different answer, most always. And so we're pretty much always going to set it like this. And this represents the answer. But what I'm saying is, here it's kind of ambiguous. It's hard to tell which one comes first. Whereas here, it's obviously the inner one comes first. And so basically whatever's closer to the X, it's closer to X in both notations. All right, let's do this one. So we're supposed to find f of g of x, so I would write that out first. Basically just keep in the same order as it is written. And then f, let's see, lay that out first. And by the way, g is just x plus 3, so the question is really the same as if it asked what is f of x plus 3, which we've already done. So once again, you lay out f, it squares it, doubles, subtracts 1, and then what goes into f? G. So put x plus 3 there, and then just simplify. What is x plus 3 squared? Plus what? Good, because you do 3x doubled, and then the plus 9 in the end. And then double everything, you get 2x squared plus 12x, and then that's going to be 18 minus 1 is 17. And then here, that equals the composite function, f composes g. Okay? Now the next example is the same functions, we're just doing the opposite, we're doing g of f. And you'll see it's not going to work out the same. So all g do is add 3 onto the input. And so put f in there. You didn't really need the parentheses in this case. They don't hurt though. And so we just get 2x squared plus 2. Much easier, much nicer. There. You don't have to label the answer. It's kind of nice. They have brackets here. If you put parentheses, same difference. I don't care. Okay, I put parentheses in this one. Okay? Now, next example, we're still using the same functions. Now it wants f of g, or f composed of g, of 2. I'm going to do it two different ways. First, I'm just going to go and do f of g of 2. First, you want to figure out g of 2, which is what? 5, right? And so now that means you're doing f of 5. That's what you need to get is, with these composite functions, you have your initial input, 2 in this case, is going into the inner function and coming out as a 5, and then that output from the inner function is the input to the outer function. And so if you plug a 5 into f, into the outer function, you get 5 squared is 25, double is 50, minus 1 is 49. Now that's one way to do it. But the fact is, we already know f of g, f composed of g of 2, or well, of x. We did that as the very first example. We get 2x squared plus 12x plus 17. So I can do 2 times that input squared plus 12 times that input. Did I get that right? 2x squared plus 12x minus 17? Or plus 17? Okay. Well, this is 4 times 2 is 8. It's 24. which adds up to 32. 32 plus 17, same answer. So, if you're given the same pair of functions and they ask you to find f composed of g of 2 and then 5 and then 6 and a whole bunch of them, then you might choose to find the composite function first and then use that. Or just do one then the other. Frankly, sometimes the composite function is much simpler than this. It would definitely pay to choose one way or the other. But either way works. Okay? Questions? Then, all right. You want to do this one? Actually, yeah. You try this one. If you're totally lost, then you can, or if you just want to check your answer as you go, I'll be working up here, but try not to look. Check your answer when you're done. For the third part, I showed it both ways. Just plugging in G and then taking that answer and plugging it into F. Or using the answer, the function from part A. And just plugging 3 into that. Some problem like that, I don't care which way you choose. Frankly, if this was the only question, I wouldn't take the time to find the composite function first and use it. I would just plug it in one and the other. But here we did have that at hand, so that's nice. All right. Let's try this one. Listen, before we get into this, I don't know that any of these will actually simplify, but they might. And so there's a couple of algebraic identities that you're supposed to know. I want to remind you of. If they don't come up in this unit, they will in the next unit for sure. Okay. And when I say algebraic identities, you don't have to write these down, but we used these recently. That can be replaced with this, whereas that can be replaced with this. But an identity is an equation that's always true, and we use it to simplify by replacing one expression with another. So here, I'm saying if you take the square root of something squared, You don't get x, actually. You get absolute value of x. You're supposed to know that. And then if you reverse it, it's not the same. Here, once again, the point is, you're squaring first, and when you square something, the answer can't be negative. And so therefore, there's no way it could ever produce a negative. Does that mean it's always positive? No, it could be 0. Yes, good. And frankly, if you type this left side in the calculator, you would see absolute value. That's what you see, so it's true. This one's different, because here you start out with the square root, and you can't take square root of negatives, so you can't plug negatives into this at all. You type this in the calculator, what you'd see is y equals x, but not the whole thing. So what you're supposed to know is it's this, actually. Y equals x, but only the non-negative part. Okay? So I'm saying those are identities you're going to use. They only apply if you have, well, here, let me just show you real quick. If I had something like this, could I simplify it using these rules? Yes. That cancels, and you get absolute value of that. Whereas if I had this, it's not the same. You can't do that. It has to be in the form something squared, and then square root of that. That's the only way it's going to cancel. All right? So, let's try this one. I'm supposed to do f of g. F composed with g. So f is on the outside, and then g goes in here in place of x. Now, you have to try to simplify these things. First, so you cannot just cancel square root as it is. Let's simplify the radicand. This part becomes x squared minus 2x plus 1. Then you have minus 1 in the end. And then that's just x squared minus 2x because the 1's 0 out. And that, you can't express this. That's not something squared. It's not. You can factor it. It's x times x minus 2, isn't it? But either way, you're not going to be able to get rid of the radical. So I'll take the answer in either form, by the way. Simplified form is always good. Factored form is also good. The way we initially had it, by the way, was neither. So I'm saying I'll take it fully simplified, or I'll take it in factored form. But that's the two I want. Okay? And then you just can't simplify anymore. Nothing cancels. Try the next one. We're doing f of g again. So f, basically you just put that as the denominator in f. You replace x with g, and you get this. So could they have simplified g before they gave it to us? No, because once again, it would have to be x minus 1 squared. That could have been simplified. What they gave us can't be. This is fine the way it is. Just let me show you one thing you could do in theory. I'm saying you can multiply by the square, basically multiply top and bottom by the denominator. And what you'd get is this. When you multiply a radical times itself, it just becomes like the whole number. And this is nice because the denominator doesn't have a radical, but we're just not going to bother. If it was a plain number, then like 1 over square root of 2, you're supposed to rewrite it square root of 2 over 2, right? By multiplying by square root of 2 down the bottom. Both expressions, we're not going to worry about it generally. Unless there's some great benefit more than what you saw here. So we're done. Now we'll do this one. It's really quick. All you're going to do is put g in place of x again. So, should let you try that one. Sorry. But we're done. Now listen, finding the domain of the composite function can be tricky. And tomorrow we're going to go back and worry about domain. For now, I just want to do the algebra. All right, let's try these. Frankly, these are like little puzzles. And there's more than one answer to this. So, here. I'll put it this way. If you look at H does three things. it does reciprocal of, it adds to, and it squares. Of those three things, which comes first, by the way? Actually, if you plug something in, you'd add to, then square. And then finally, you do the 1 over, reciprocal of, okay? So what I'm saying is we're trying to break this up between f and g. And so, here, I'm going to show you two options. You could say f is 1 over something. It's reciprocal of the input. And then if that's true, what is g? More than that, actually. X plus 2 squared. That's a valid answer, okay? So if you compose these two, all you do, we're trying to get f of g. If you put g in place of x here, don't you get the original? So that's a valid answer, like I said. Not the only valid answer, though. Another thing you could do is say, well, think of it this way. The function does three things: adds to, squares, and reciprocal of. G did two of those, and f only did one. Well, let's take some of the load off of g. If g is only going to do one of these two things, which one has to stay with g? The adding to or the squaring? The first thing, the adding to, has to be part of the inner function. That's what comes first here, yes? And g is the inner function on this because that's the way they set it up. So I'm saying the x plus 2 has to be part of the first thing, the g. But that means what does f have to do? It has to take whatever is given, square it, and do reciprocal of that. And you put x plus 2 in place of x here, you get 1 over x plus 2 squared. That works as well. So that's pretty the only two answers you're going to get out of this. All right, we'll do this one together. I'll let you try the next one. To figure this one out, you have to factor it out first. So go ahead and pull out a common factor of 3. And then factor out that. What do you get when you factor that? Yeah, what two numbers multiplied before but also added before? 2 and 2? Minus 2 and minus 2? Which means our function, h of x, could be expressed as 3 times x minus 2 squared. Okay? What three things are happening here? Well, you triple it, you subtract 2, and you square. Not in that order. So I'll leave it to you. Figure out a way. There's more than one way. Come up with two functions so that when they're composed, they equal this. And there'll be two answers here as well. Now, thinking of order operations, Jeremy, what is the first thing that would happen if you did this? The subtraction of 2, the squaring, or the tripling? Squaring's not the first. Eddie? So that's first. What's last? The tripling, right? If you did order of operations, if you had an x value, you subtract 2, then square it, finally you triple, okay? So what I'm saying is, the tripling has to come last. It has to be part of f. The minus 2 has to be part of g. Where the squaring goes is your option. So in other words, here, Chris, give me your answer. And so he gave g the responsibility of subtracting 2 and squaring it. And then that goes in place of x here. Then f would just triple what is given. That's one way to do it. The other way is to give g only responsibility for subtracting 2. So f has to do squaring and tripling. You try this one. There's no simplifying or anything to do. So just figure out it. So in everyone's answer, the divide by 3 had to be part of f. Someone want to share? Chris? Wait, didn't I get yours last time? Didn't I already get an answer from you on this? I'm gonna. If no one else answers, then I'll let you answer. But I want to give someone else a shot. Janelle? That'll work. What did I just do? So F, she has to do two things: the square root and the division by 3. Div, which of those could I move to G? The square rooting or the division by 3? Because the division by 3 has to come last, so it has to stay in F. So, yeah. And if I move the square rooting came after. And seriously, watch. If you wrote this, you'd be wrong. Because we're not square rooting and then subtracting 1. We're subtracting 1 and then square rooting. Okay? Now, I'm going to change the question. So just watch. You don't have this on your paper, so just watch. So I'm going to make up three functions, m, n, and x. They're going to correspond to the 3 things happening. I'll kind of randomize this. We'll say x is the division by 3, and n is the subtraction by 1, and that means p is the square rooting. Okay? So, if I which of these would happen first? I'll put it that way. N is the subtraction 1, so that's our inner function. So my goal, once again, is to express h as a composition of these 3 functions. This came first. What comes next? Because square rooting comes next, p comes next. So p of that, n's inner, then p, and then m is the outer function. Okay? We're going to go back and do that on all these. So once again, I want to do the same thing, but I want 3 functions. Here, we're looking at this. Yeah, I was trying to decide who to ask. That's okay. Jacob, what do you want n to be? -2 or square? Okay. Well, it doesn't matter. It's your choice. Okay. And then that means that the subtraction by 2 must be the other. Be there. Kendall, what comes first? P, n, or m? The x minus 2 is first, so yeah, p is the inner function. Div, what comes next? M or n? Say it again? Yeah. It's hard to distinguish the two because the squaring comes next, according to order operations. So h could be expressed as a composition of those functions in that order. Yeah. All right, let's try to make sure it's not alphabetic order. All right, close your eyes. Close your eyes. I'm going to change the letters, by the way. Are you leaking, Jacob? Better not be. Keep your eyes closed. Keep your eyes closed. It shouldn't be that hard, but... do not open your eyes, because I have to figure out the answer. And I'm feeling particularly obtuse right now, so... Okay, raise your hand as soon as you know the answer. Yeah, open your eyes. Eddie? Let's see, the inner function C, then squaring comes next, so that's A, and then finally take reciprocal, which means he's right. Nicely done. It's illegible. Alright, that'll do. Listen, well, I'll say this again. We did all the algebra, like found the answers, found the composite function. We haven't spoken about domain of composite functions, because like I said, it's tricky. We'll tackle that tomorrow.